Alright, boys and girls, let's continue with our fantastic blocker blockchain. So basically, the previous episode, the previous lesson, let's do a make run real quick. Wait, let's first of all do my settings a little bit bigger for the blind homies. 18, and then we're gonna do one here, to be honest. Yes, let's go to main or something. Alright, so if I remember correctly, we did some mempool stuff, and to be honest, I was thinking, we actually need to add a mutex there, so I'm gonna quickly do that. And then we're going to add blocks to the chain. We're gonna make our Genesis block. Still no validation, because for validation we need to basically have some state, not some state, but we need to save some stuff so we can actually validate with UTXOs and all that stuff. So it's a little bit complicated, but we are getting there, So mempool, right? So we have this mempool thing. What I want to do basically is I need a sync mutex in this case. So I'm going to say it's going to be an R, let's call it lock actually. It's going to be a sync RW mutex, and then what we're going to do here, if we have a hash, we're going to say pool lock. It's going to be small caps actually. Pool lock R lock, and defer pool lock add unlock, right? Just like that. Let's make a space. For add, we're gonna do, we need to be careful here, because here we are already locking in the hash thingy. So what we're gonna do here is pool lock and pool lock unlock, right? Just like that. Actually defer. Yes, that should be good. Then we also need a len function, because we are using that function pool mempool. We're gonna say len, which is gonna return an integer, and we're gonna say an R lock. We're gonna yang this actually for boom, paste it in, and we're gonna return the length of the pool txx, right? That's what we're gonna do. And also, what I'm gonna make is a clear function real quick, and you wanna see why. Pool mempool. It's gonna be caps actually. It's gonna be a clear function. We actually is gonna do exactly what this function is all about. We're gonna clear the mempool, but we're also gonna return a slice of proto transaction, because we need that to add to our blocks, right? So in clear we need to have the lock, so I'm gonna try to copy it from here, yoink, the whole shebang, paste it in. Then we're gonna say that txx is gonna be make me a slice of proto transaction. It's gonna be the length of the mempool. We are already locking, so it's fine. Pool txx. Then we're gonna actually loop here over the key and values in range. Pool txx, which is a map, right? So we need to be careful. We need an iterator here. So we're gonna say it is gonna be 0, and then we're gonna say delete me in pool txx the key, but we're also gonna add txxy is gonna be v, right? It actually, and we're gonna increment this iterator, and then we're gonna return txx, yes, and that's a clear function. So why are we gonna use that? And we will see. Where are we doing the shenanigans? It's in mempool add here, that's fine. Validator loop here. So basically, we are ranging here, so we're gonna delete that, right? We're gonna say here txx is gonna be n mempool. We're gonna clear a whole shebang, and then we're gonna say here is gonna be the length of the txx. That's fine. So basically now we're gonna clear the txx. We're gonna clear the mempool. with the transactions, and these transactions we're gonna basically forge into a block. That's the thing we're gonna do. So we're gonna say make run and see what's going on here. Drinking some coffee along the way. Length 2. Length 3. It should reset now, actually. Yes, length 2. Yeah, it's fine. So that's working perfectly fine. What we could do is, where are we making transactions? 1 each second. So maybe we could do a speed up, and so 800, and make this millisecond to see what's going on here. If we don't lock ourselves out in our mutexes. Let's see what's going on. That sounds good. 6 transactions in the block. 7 transactions. 6. 6. Okay, it's fine. We're doing good. We're doing good. 8 millis. Can we go even faster? Of course, there's no consensus algorithm, so it actually just look at this. 29 transactions I saw real quick. 48. 49. 50. Let's see what's going on. 49. All right. Sounds good. Sounds very good. Very good. Okay, cool. So what we're going to do now is basically prepare everything for adding blocks. So, Note. No. Chain. That's the way to go. So what we're going to do is we are going to do some kind of Genesis block. Actually, let's first do this. Let's first do a simple validation here. We're going to say C, which is going to be a chain. And this chain is going to be a validate block, actually. It's going to be a B, it's going to be a proto block. And we're going to return an error here. What's going on? So the first validation we're going to do, we cannot do all the validations, but we're going to do the first one. And that's basically, we are going to check, the pref block, which is actually the current block. The current block error is going to be C get block by height, which is going to be C height, right? The current height of the chain. If there is an error, we are going to return that thing, return the error, right? And then we're going to say, we're going to compare, because that's a new block, right? This B thingy is going to be a new block. And the current block will be, actually, the previous hash of the new block will be the hash of that current block. So when you're going to check that, you're going to say if bytes equal, what's going on here, man? It's still early in the morning. But hey, bytes equal is going to be current block. That's going to be the, actually going to hash that, to be honest. We're going to say hash. It's going to be types, hash block, the current block, right? And then we're going to compare the hash with the bpref, header pref hash, right? And if that's not equal, we are going to return fmt error f invalid previous block hash. Actually, we could do it like this. Boom. And in this case, we're going to return null. Of course, we're going to do more validations, but hey, that's it. We're also going to check, basically, if the public key, the signature. We could actually verify the signature also. Yeah, that's also what we could do. But the problem is we don't have... I'm thinking real quick. Actually, let's first do this. So the problem is, if we do validate block here, right? If we do we have add block. So first of all, what we're gonna do is if C, if R is gonna be C, validate the block is B, and the error. What's going on here? And the errors are not nil. We're gonna return an error here, and we're not gonna add the block, right? That's for sure. So the problem is if we do a make test, I think everything is gonna fail. Yes, we have some fails, and that's because we're validating a block, and we cannot validate this because we don't have pref hashes set in our tests. What we're gonna do first is make something like this. We're gonna say create Genesis block, right? And that's gonna return a proto block. We're gonna say the block is going to be proto block. Of course, we're gonna not completely make the Genesis block. It's gonna be a simple placeholder for later on. It's gonna be the header. It's gonna be an n proto header. Proto header. We need a version. It doesn't really matter actually. The pref hash, we don't want to set that thing. The hash, what do we need to set in this header actually? We actually don't care, I think. What we also gonna do real quick is what we didn't do in proto. You see, we have our block here, right? And it's important that we have a public key and a signature, because somebody's gonna sign that block, and the public key belonging to that block is basically the guy that's is the public key from the private key that signed that block, right? So we're gonna say something here like bytes public key is gonna be 3, and then we're gonna say bytes signature. It's gonna be 4. Let's clear this. Make proto. All good. So let's delete this, and then we're gonna say here. Actually, I want to go to types real quick. No, block go. Yes. So in sign block, what I want to do is basically say that the signature. And then we have a hash is going to be hash block of B, and the signature is going to be pk sign the hash, right? And then we're going to say, because we have access to this pointer to a block, we're going to say that the block public key is going to be pk public bytes, and the B signature is going to be the sig bytes, right? We're gonna set that, and then we could return this if we want. We're gonna return the signature. We're gonna return the signature. Yeah. That's what we're gonna do. Boom. Let's sign block. That's fine. So of course, create Genesis block. We should have some kind of a private key that's deterministic, right? But hey, we're gonna generate a new one. We will fix that later on. We're gonna say pref key. Because now, right now, the Genesis block will not be deterministic at all times, because each time you're going to create this Genesis block, it's going to generate a new private key, and it should be one from a seed, right? Pref key is going to be crypto generate private key. And then we're going to say we're going to make the block here real quick with nothing in it. It doesn't really matter. And then we're going to say pref key. Actually, it's not true. We're going to say types sign block pref key block like that, and then we're gonna return that block, and that should have a signature normally. Yes. And then we could we're gonna actually create the Genesis block with new chain here. Problem is we cannot validate Genesis block, right? We cannot validate that like a normal block, because it's a Genesis block and we don't have a pref hash and all that stuff. So what we're gonna do is we're gonna create an internal function, a private function. It's gonna say chain. We're gonna call this add block like this. We're gonna say b proto block. It's gonna return an error just like normal. and we're gonna copy everything here, right? We're gonna delete that actually. We're gonna paste that in, and here we're gonna say return C add block with the B, right? But in add block it will be a validation, and this add block will be without validation, right? And in this case, what we could do is in chain, you could say here that the chain is gonna be our chain. Then we're gonna say chain add block is gonna be create Genesis block, and then we're gonna return the chain. So we have our Genesis block each time we create that new blockchain. All right, that's fine. Of course, if you open up our test here, block test, we're gonna have some problems, right? I think it's not block test. This is fine. Wait, this is test sign block. Maybe we should actually refactor this. Assert equal T block. The public key of this block should be the same as the pub key. That's not true, because pub key gonna be pub key bytes. Yeah, and then we're gonna say that the block signature should also have the sig bytes. That should be fine, and if that's okay, then I'm good. Yes. Test hash block, that's fine, that's fine. We're gonna chain test, I guess, right? Chain test, that's what we need. So test add block, test chain height. So basically, first of all, let's create a new test to see if the Genesis block is created. So we're gonna say test chain, new chain actually, new chain, T, testing T, boom, boom. Let's copy this, paste it in, and then we're gonna say assert equal T0 chain height. Just like that. And then what I'm also gonna do, yeah, that should be fine. Is that true? That's true. The chain height is 0. And maybe we should do Genesis block is going to be chain get block by height, and that's going to be 0. We're going to assert nil tr. Actually, do we need to block? Should be fine. Let's run this test. Yes, okay, cool. So we don't care about the block. The only thing we want is that this block exists, right? That the block exists in the chain. That's fine. Okay, the next test basically going to fail is this chain height thingy. It's going to be a problem, invalid previous block hash, right? Because we do a validation. We check the previous block hash, but we don't set it here. So what we're going to do is we have a random block here, and then we're going to say that the prev block R is going to be chain get block by height, and that's going to be the current height. Assert nil tr, and then we're going to say b header prev hash is going to be the prev block prev hash. Prev block. Yes, right? And then we should actually test this. We have an invalid thing. How is this possible? B. What's going on here? What is going on here? Let me quickly see. So we test this. Invalid prev block hash. I see. Are we doing it okay? Where is validation here? So we have We get the current block by the current height. We hash that block. The hash is hash block the current block, and then we're gonna compare these two hashes. Wait, what is going on here? You see, sometimes we have some troubles. So what we're gonna do is we're gonna actually comment this real quick out. We're gonna say, we're gonna copy these things here. Actually, what we could do is, instead of commenting everything out, is just comment these for loop out. Assert equal chain height. That's gonna be, let's comment that out. So we're gonna make a new block. We're going to say that the pref block is chain get me the block by the current height. We're going to set that real quick. The b header pref hash is going to be the pref block header. Oh, no. This is a problem. This is a problem. This is not true. This is not true. I see. Because, no. We made a mistake here. The b header pref hash is going to be the same thing. That's going to be the types hash block of header. It doesn't really matter. It's going to be hash block the pref block, right? That's what we need. And then we're going to add that, right? Yeah. That's the thing. Okay, cool. So now we have a problem with the iterator. That's fine because it works perfectly fine before we added the genesis. Now we have the genesis, so we need to do +1, right? +1. Boom, now it's everything fine, right? The next test is also going to fail because we need to do the same thing. We need to get this block. Maybe we should make a helper function for that. Maybe. Assert nil add block. We're going to paste that in here. B is going to be the block types hash block. The problem is that this hash should be calculated after we had set the header, right? So this can actually be this. No var, it's fine. Then we're gonna assert all this stuff. Fetch block by hash, all that shebang. Let's see if this works. Boom. It's gonna be, ooh, what is this? Not equal, I see. I think this needs to be I +1. What's going on here? I think now it's fine. Yes, okay, cool. That's good. The next thing we're going to do is we're going to do another validation. Let's open up chain. In this validate block, we're going to do the signature, right? This is basically validate if the pref hash is the actual hash of the previous block, of the current block actually, of the highest current block is fine, right? Then we're gonna say validate the signature of the block, right? That's fine. So how do we do that? Do we have this in blocks itself actually? I don't think so. So we have sign block, hash header. Let's make a function. We're going to say verify. It's not validate, it's basically verify block. And that should be a bool maybe. And then we're going to say basically do we have, I think we have that in signature is going to be crypto. Signature from bytes, right? Signature from bytes, and that's going to be verify block. Of course, we need to have the B. And normally you could attach these functions basically on a receiver from the block receiver, but we can't because it's a generated proto buffer file. But it's actually the same concept, right? Proto block. It's more a C type approach, and I like that because I'm a dirty C developer. That's not true. I like C. I really like C and Go. That's why I love Go also. Crypto signature from bytes, that's going to be B signature, right? And we could also do something like the pub key. And that's going to be crypto pub key from bytes. It's going to be the B pub key, right? And then we could do something like return sig verify. It's going to be the pub key, I guess. And then we need a message, I guess. We're going to say the hash is going to be hash block B. You see, I really like the way we set up these functions like this. Let's verify block. We should make some tests in this. That's true. Do we have block test? Test sign. Test sign. Verify block. Right, so we're verifying it here, that's fine. We could also do something like assert true. T. Verify block B. Block. That should be fine. That's good. What we also should do is basically do something like this. Pref key invalid pref key is going to be a crypto generate private key. We're going to say that the block public key is going to be invalid pref key bytes, and then we're going to say assert false. What's going on here? Help. Assert false. Verify block. That should be false because we set an invalid public key. Invalid public key length. Wait. It should be public actually. What are we doing here? That should be fine. All right, so that's false. That's good. What you also could do is, before we do this invalid public key thingy, is do block actually a bad hash. It doesn't matter. It's gonna work perfectly fine, right? Okay, so that's good. So what are we doing? What are we doing? The problem is right now these tests are going to be nasty because we are doing validation here, invalidate block, and our tests. It doesn't matter. We're gonna fix it. So what we're gonna do is actually very simple. We're gonna say if types validate, verify block actually, verify block B, then we're going to actually say here return fmt error f invalid block signature. That's it. Of course now all the tests are going to fail, right? Because we don't have a signature, right? What is make run actually is a problem. We're going to say make test. So it's going to be a complete failure, right? And we're going to see here invalid length, and that's because it's a panic actually. That's because it's an invalid length. What we're going to do actually is, we should actually fix that in verify block, to be honest, because these panics. I'm going to do something like this, right? If len b public key is not 32, return false. If len b signature is not, actually, do we have this in crypto? What we're gonna do actually here is we're gonna make this public. These two, maybe address len also, and clen. Actually, let's make everything public here. We could actually do replace all occurrences actually, but hey. Address len. Then we have signature length. That's fine. And then we're gonna say here, there's gonna be crypto pub key len, and then here is gonna be crypto signature len return false. That's good. And now we could do a make test. And now we're gonna have a clean thing, right? So now we're gonna see. The problem is that we should use something else in these tests, to be honest, in these block tests or in the chain tests. We will see why. Because we do assert equal. I think we should do require in these things here. Require. Actually, I want to change all these occurrences here. How can I do this? Require. That's fine. Because now, if you do make test, you see it's going to stop with the first error, and I think that's good. Undefined, where's this key test? Undefined, yeah, it's key test. Okay, cool. Key tests. Like this, and like this. Boom. All right, so it's going to fail. That's true. We're going to say invalid block signature, invalid block signature. That's exactly what we want. So how we're going to fix that is by signing blocks, right? In our block test, chain test, which is a little bit nasty, but hey. How are we going to do this? I think we could do something cool here. Let's make func random block t testing dot t chain chain, and it's going to return a proto block, and it's actually a test helper, because what we're going to do here is we're going to basically create a random block, set the header like this, get the height, pref header, and then we're going to actually make a pref key here, pref key generate crypto, actually generate a private key, and then we're going to say types sign block pref key, where is this b here, return b, just like that. And then yes, random block, that's fine. Then we're going to say here we can delete all this stuff. We're going to say b is going to be a random block t chain, and we're going to do the same thing here, random block hash. We're going to delete all this stuff. We're going to say block, in this case it's going to be a random block, and that's going to be t chain. That's fine. Hash the block, do that stuff. Is this it? Yeah. Look at this. Good. All right. That's fine. So now we can add blocks. That's pretty important because right now we have an ability to add blocks. We verify, we do some small validation. Of course, we need to verify each transaction and validate each transaction. If it's spent or not spent, can we spend it? So that's, but in able to do that, we need to basically have something to store the UTXOs so we can easily fetch them and all that stuff. And that's going to be for the next episode because it's going to be an episode, a series, a lesson on itself. It's pretty important to know, and it's also, it can be some complex to understand, and we need to do a lot of stuff for that. All right, I'll see you in the next episode.